Okay, number F, letter F is, you can pull out a 6 from the 36, a k from the k squared, a p to the 5th from the p to the 10th. So it's just 6k p to the 5th. And then G is, let's see, 480 we have to break down. 48, 10, 2, 5. 4 perfect square times 12, 4 perfect square 3 prime. Okay, so that's going to give us, this one has a lot of stuff under the square root. We have a 2, 3, 2 4s, 2, 3, 2 4s, a 5, a k squared, and then the r to the third, you want to have things in even exponents or pairs, because even exponents are perfect squares. So what I have to do for r to the third is pull out one r, and then I have r squared left. So 2 is stuck under the root, 3 is stuck under the root. The 2 4s, I can pull out 1 4. 5 is stuck. I can pull out a k from the k squared. The r is stuck, he's not paired up, but of the r squared, I can pull out an r. And that is going to leave me with, so these 3 get multiplied together and put in the front. 4kr, and then under the square root, we have 2 times 3 is 6, times 5 is 30, and r, which I almost lost the r. Okay, number H. I can't do any simplifying here, and it looks like everything's a perfect square. So I'm going to get x to the third, y squared on the top, right? You just divide the exponents by 2 to get the square roots, over 10. Okay, 75. I did a 75 somewhere, I thought. Maybe not. 75 is 25 times 3. And so I can do some canceling here too. So let me do this. Well, I'm going to cancel first. That's always best. I'm going to cancel these 2 b's from these 4, and I'm going to leave 2 b's on the top. So I don't really need this huge square root, but I have a 25 times a 3 times a p to the 6 times a b squared now, still under the root. So I can pull out a 5 from this guy. 3 is stuck. I can pull out a p to the third from the p to the 6. I can pull out a b from the b squared. So I end up with 5b p to the third, order doesn't really matter, but this is alphabetical, times the square root of 3. Okay, I, 98, is 2 times 49. Okay, so that's gonna be 2 times 49, x to the 4th is fine as is. Now y to the 3rd, that's an odd exponent, so I need to make it even, so I'm gonna pull out one of the y's, which leaves me a y squared, right? Because that's a 1, so these 2 would add to make the y to the 3rd. 2 is stuck under the root. I can pull out a 7 from the 49. I can pull out x squared from the x to the 4th. Y is stuck. I can pull out a y from this y squared though. And that's going to leave me with 7x squared y on the outside times 2y stuck on the inside. Okay, now this one, actually the next 2 are the perfect squares. And just to show you that they check out, right? 7x doubled is 14x, so it checks out. That means what's underneath there, if I factor it, it's x, the first sign goes here, squared. Now anything squared has a square root, which is just x plus 7. Okay, and then on L, same kind of deal. That's a square. You could also factor it by trial and error. Oops, 2m is the square root. 2m times 3 is 6m, doubled is 12m, so the middle term checks. And it's a perfect square, so 2m, now it's minus 3 squared, which means the square root of that is just a 2m minus 3. Okay, back to factoring, which I'm sure you're really excited about. Going through here quickly, now there's no primes. So number 1 is trial and error. And these two have to multiply the x to the x squared. The last two have to multiply to 63. And then the inner and outer have to make 16. So I know that 9 times 7 is 63, and that can get to a 16. So 9, 7, but they have to add to a negative 16, and the last has to multiply to a positive 63. Okay, next one, remember to follow the checklist. There is a GCF here of k, so I'm going to pull that out, and I get 7k plus 9, which is nothing here. I can't do anything with it, so that's the end. I'm going to go kind of fast through these factoring ones. All right, number 3 is just the difference of two squares. So n plus 10, n minus 10. 4, there's no GCF. I'm gonna check to see if it's a perfect square. So 9p doubled is 18p, so it's p plus 9 squared. And then 5, no GCF, but it is the difference of two squares. So it's 2y plus 5, 2y minus 5. Remember how one's plus and one's minus with the difference of two squares? Whereas a perfect square, it's p plus 9 times p plus 9. So if you did this by trial and error, if it looks like this, that is fine. Okay, number 6. Looks like it could be a perfect square. There's no GCF, so let's check. 3y, 4x. That's 12xy doubled is 24xy. So 4x minus, first sign goes here, 3y quantity squared. 7, there's a b in all terms, so I have to first pull out the b. 3b squared minus 5b plus 2. All right, that's a GCF step. Then I'm looking at this. It's not the difference of two squares. It's not a perfect square because the ends are not squares. So I'm going to try trial and error. I know it works because I've done it before. 3b times b makes the first term. Now the last, this is kind of tricky because if you put, let's see, I'll just do it. If you put a 2 and a 1 here, it seems to work, right? You get a 1 and a 6. So you could go minus plus, that gives you 1 plus negative 6 does make the negative 5, but look at the last term. This multiplies to a negative 2. So that actually doesn't work. Instead, 3b, put the 2 and the 1 here. 2 and 3 can make 5 if I make both of them negative. Negative 2 plus negative 3 makes negative 5, and the last one multiplies to positive 2. That's the answer. Okay, number 8. No GCF. Looks like trial and error. 7x and x. Now I have to get to something kind of big. And so I know that 7 times 4 makes 28. I'm going to put the 7 here because that's going to get me to 49. So now I can go minus with the 49 plus with the 4. 4 and a negative 49 makes 45. And then the last multiplies to a negative 28. FOIL them to check them, make sure they work out. Okay, number 9 is grouping. So parenthesis, there's no minus in the middle, so I don't have to make a sign change. Pull out the GCF from each group. P minus 7 plus, I can pull out a 10. P minus 7. These two parenthesis parts need to match for it to work. And then I get 1p minus 7, and then the outside stuff, m plus 10. Okay, that's got to bring some flashbacks. Okay, number 10, pulling out a 2, I get x squared minus 4x plus 4. Looks like a perfect square here. Okay, so I get, don't forget your GCF in your answer. X first sign 2, or if you did 2 times x minus 2 times x minus 2, that's also fine. Number 11, pulling out a 5 first, GCF. I get that, step 1. Step 2, that's the difference of 2 squares. He's going to break. So the 5 carries down, and then the difference of 2 squares is y plus 2. Y minus 2. Okay, number 12 is grouping again, has 4 terms. So parenthesis, parenthesis. Now that's minus in the middle, that means you've got to change the last sign. Don't touch the minus in the middle, it stays minus. I'm going to pull out a 7y from the first group, and I get x plus 4 minus, pulling out a 3, x plus 4. So then it's x plus 4 times 7y, the outside pieces, minus 3. Okay, and then looks like trial and error because there's no GCF. So P, I know 7 times 2 can get to a 5. If I make that 7 negative, that positive, FOIL it out, it checks out. And the last one, trial and error. M times M. 4 times 2 can't get to 9, but 8 and 1 can if I make both of them negative. And then the last one will multiply to positive 8. Voila.